So today we're going to talk about solving using the quadratic formula. Now the quadratic formula is effective, but it's also very tedious, so it's not our first choice solving method. If we're able to solve by factoring or solve by square rooting, those are our first choices. So when I take a look at this problem, I see that it's in standard form. I see that we have both an a term and a b term. So we have both an x squared and an x, which tells me that we're only going to be able to solve this by factoring, or if that doesn't work, then using the quadratic formula. And I always want to start out by seeing if we can factor. So I'm going to draw my area method and my area model. And so I have my 2x squared and my 1. And I'm remembering that I want these two spots to sum to 4x. So I'm thinking about what multiplies to make 2x squared. And really, we only have one option. That's a 2x and an x. And I'm asking myself, well, what multiplies to make 1? That's just 1 and 1. Or negative 1 and negative 1. So, those are my only two options. So when I check this out, I have 1 times x is 1x, 2x times 1 is 2x, and when I look at that, 2x plus 1x, that is not 4x. So then I say, okay, well, what if I have negative 1 and negative 1? If I have negative 1 and negative 1, that becomes negative 1x and negative 2x, and if I add those, I get negative 3x. I still don't get that positive 4x that I'm looking for. So I know I have exhausted all of my options because nothing else multiplies to make 1 and nothing else multiplies to make 2x squared. So whenever I have exhausted all of my options, that's how I know, okay, factoring did not work as a method here. So now I'm going to have to change my strategy. So it's always worth that time to check and see if factoring works, though, because otherwise jumping straight to quadratic formula is going to kind of mean that it slows you down. So our quadratic formula we have here, and we know that it's opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And we have to ask ourselves, what is a, b, and c? A is always going to be the coefficient of the x squared. B is always going to be the coefficient of the x. And c is always going to be that constant. And so when I go to substitute these in, I have 4 is b, so negative 4, because that's how our formula is set up. And then we have 4 squared minus 4 times 2 times 1, all over 2 times 2. And so we are going to simplify. Let's see here. And so we get x equals negative 4 plus or minus. And we just want to take our time with this and make sure that we're being really precise. So 4 squared is 16 minus 4 times 2 times 1, so that's 8, all over 2 times 2, which is 4. And so I get negative 4 plus or minus the square root of 8 all over 4. Now, a lot of us are going to be tempted to just cancel this 4 and 4 here, but we have to remember that we want to make sure that we recognize that all of this is up in the numerator of this fraction. So each term in the numerator of this fraction needs to be divided by 4 if you're going to simplify. Now, we can't divide square root of 8 by 4 because the 8 is inside a square root, whereas the 4 is not. So we are going to see if we can reduce that square root of 8 any. So we know that the square root of 8 is the same thing as the square root of 4 times the square root of 2. And that's going to allow us to reduce this. And so we know the square root of 4 is 2. So when I'm looking at this, I can't quite divide everything by the 4 that's in the denominator, but I can think about the 4 as a 2 times 2 and think about dividing both negative 4 by a 2 and the 2 root 2 by a 2. And so that will cancel that 2 out. So I'm going to get negative 4 divided by 2 is negative 2. 2 root 2 divided by 2 is just root 2. And then we still have one of the 2's left in the denominator because we only divided negative 4 and 2 root 2 by 2. We didn't divide it by 4. And so that is our most simplified solution.